Saturn, the perfect hexagon. Nature doesn't do straight lines. Clouds swirl, storms spiral, winds bend and twist with rotation and turbulence. Fluid systems prefer curves. They evolve through instability, not geometry. And yet at the North Pole of Saturn, there is something that appears almost designed. A near-perfect hexagon, 6 straight edges, 6 corners, roughly 30,000 kilometers across, wider than Earth's diameter. It looks engineered. It is not. Saturn is a gas giant. There is no solid surface beneath its clouds, no continents shaping airflow. What we see is atmosphere all the way down, layered, dynamic, driven by internal heat and rapid rotation. Saturn rotates once in about 10.7 hours. That speed stretches atmospheric motion into powerful east-west jet streams that circle the planet. These are called zonal jets. On Earth, jet streams meander and shift. On Saturn, they are stronger, broader, and often more stable. Normally, atmospheric motion produces familiar shapes, circular vortices, spiral storms, chaotic turbulence. Straight edges are rare in fluids because fluids continuously deform. They resist rigid boundaries. And yet, near Saturn's North Pole, one jet stream does something extraordinary. First observed by the Voyager spacecraft in the early 1980s and later captured in extraordinary detail by the Cassini mission, the hexagon has remained visible for more than 4 decades. At its center sits a massive polar vortex, a hurricane-like storm rotating. Within the 6-sided boundary, the entire structure rotates around the pole, maintaining its geometry with only slight oscillations along its edges. Storms on planets typically evolve and dissipate. Jet streams shift. Weather reorganizes, but Saturn's hexagon has persisted. Persistence suggests stability, and stability in fluid dynamics usually implies an underlying wave pattern, rather than random turbulence. The hexagon rotates at nearly the same rate as Saturn's. Internal radio emissions, signals used to estimate the planet's deep rotational period. This suggests the structure is not drifting freely. It is tied to the planet's broader atmospheric system. Rather than being an object sitting on Saturn's pole, the hexagon appears to be the jet stream itself, shaped into a 6-sided standing wave. In rotating fluid systems, waves can become locked into repeating patterns. Under the right balance of velocity, rotation, and shear between adjacent flows, the jet can form a polygon. This is not speculation. Laboratory experiments using rotating tanks of fluid have produced remarkably similar shapes. When a central vortex spins within a surrounding ring, moving at a different speed, instabilities form along the boundary. Depending on the conditions, the boundary can organize into triangles, squares, pentagons, even hexagons. These edges are not solid walls. They are wave crests in the fluid, regions where velocity and pressure differences stabilize into repeating geometry. Saturn's hexagon is likely a planetary scale version of this effect, a Rossby wave pattern embedded within a polar jet stream, locked into 6 lobes by the planet's rotation and energy distribution. Nothing artificial, nothing mechanical, just fluid dynamics operating at immense scale. And yet, knowing the mechanism does not make it less unsettling. We associate symmetry with design. Straight lines feel intentional. Geometry suggests construction, but nature can generate symmetry when forces balance precisely. The hexagon is not drawn onto Saturn's atmosphere. It is sustained there, continuously recreated by motion itself. Why 6 sides? Why not 5 or 7? The number depends on jet speed, rotation rate, and the energy flowing through the system. Under slightly different conditions, the pattern might shift, which raises a broader question. If Saturn can sustain a stable, planet-sized polygon for decades, are similar structures forming elsewhere, on other gas giants, on exoplanets, perhaps briefly, perhaps unseen? Is Saturn's hexagon a rare atmospheric accident, or is it a stable solution to fluid equations that we simply do not recognize on other worlds? Nature does not usually draw straight lines, except here. At the North Pole of Saturn, chaos settles into geometry, not because it was designed, but because the physics allows it. A jet stream becomes a hexagon. A storm spins inside it. And a planet reminds us that sometimes symmetry is not the opposite of disorder. It is what disorder becomes when it stabilizes.